sweet students, it is, we're going to talk about factoring by the greatest common factor and grouping method. So this was our first day of factoring notes with regard to this. So just thought if you need to review them, this might help. All right, so when we're talking about the factoring by the greatest common factor, remember we're talking about basically taking a polynomial times a polynomial, and before we learned the box method of multiplying that, and if this is x and this is 2 and this is x and this is 3, when we multiply it we'd get x squared here, we'd get 2x there, it's awfully little, 3x here, and 6 here. I'm basically multiplying these two numbers to get this number, this x by this 2 and putting it there, this x by this 3, getting 3x, and this 2 and this 3 in the grid to get 6. When I do that, I combine my like terms, and I get x squared. 2x plus 3x is 5x, and that plus 6 would be my answer. So we've worked out multiplying these two to get this. So in factoring, what we're going to try and do is work backwards from this to get here. Okay, so this is the first of a series. So we're looking for the greatest common factor, and that is a number, the biggest number that divides into all numbers, not all numbers, but all numbers that we were talking about, equally. Okay, so for an example, when we have 24 and 42, the biggest common factor would be 6. We've got our factors for 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So you figure 1 and 24 multiplied together give you 24. 2 and 12 multiplied together give you 24. 3 times 8 give you 24. And 4 and 6 multiplied together give you 24. For 42, our factors are 1, 2, 3, 6, 7, then I think that's 3 goes into 4 one time, 14, and 21, and 42. So these are all the factors of 42. 1 times 42, 2 times 21, 3 times 14, and 6 times 7. Okay, so when I look at these, I look and see that the biggest common factor is going to be 6. So that's how you would work that out step by step. The biggest common factor between 81 and 90 is going to be 9. The biggest common factor between 15 and 33 is 3. The biggest common factor between 40 and 8 will be 5. Oh, I'm sorry, that's wrong. Will be 8. That's 8. All right, So if you don't know how to get the biggest common factor, what you need to do is figure out what all the factors are for that number and compare it to all the factors of the other number and determine what is the biggest number that goes into both equally. All right, moving on. So we want to look for a number or variable that each term is divisible by. Okay? So when we look at these, I'm looking at those and I know that this is 2 times 2 times x. And this is 3 times 2 times x. And the two things that those have in common are 2x. So I can factor out 2x. And when I divide 4x by 2x, 4x by 2x, that would give me 2 left over. If I were to divide 6x squared by 2x, I would have 3x left over. Okay? Now, the biggest common factor out of 15a cubed and 28 to the fifth, we've learned that our exponents, when we have the same base, what do? We add our exponents. So I'm going to be looking for numbers with these exponents that what two exponents add up to get me that number. And we'll talk. And if you don't understand what I just said, hopefully you'll understand in a minute. So I'm going to look at my numbers. 15 and 20. What is my greatest common factor between 15 and 20? That is going to be 4. Oh, no, it's not. Holy mackerel. It's going to be 5. Hopefully you guys are like, Miss LaBelle, what are you talking about? It's going to be 5. And I also have, because this is 3 times 5 times a times a times a, this is 4 times 5 times a times a times a times a times a 5 times. Okay? There are 3 a's here, and I can pull out 3 a's from there. So I can pull out 3 a's. When I divide 15a cubed divided by 5a cubed, what am I left with? I'm left with 3. When I divide 20a to the 5th power by 5a cubed, what am I left with? 4. And then we know that in our law of exponents, if we have am divided by an, that's the same thing. I've got the same base. As long as I have the same base, I can do this. M minus n. So 5 minus 3 is going to give me a squared. I also can look over here. Look, if I take away 3 a's, I'm left with 2 a's. 4a squared. Okay? So here is my greatest common factor, and these are my leftovers. That's what's left over when I take out my greatest common factor. In here, my greatest common factor is going to be negative x squared or positive x squared, either one. The numbers, there's no common factor among the numbers, but there is a factor of the x's. They both have 2 x's, at least 2 x's in it. And you're going to find that with your variables. If you have the same base, it is going to be the base with the highest or lowest exponent, with the lowest exponent. So in this case, we know that we've got 2 x's here. Well, if we have 4 x's, that of course is going to include 2 x's. So that's going to be our greatest common factor. And what's left over? 13, negative 13x to the fourth divided by negative x squared is going to be negative or positive 13x squared. So that's my leftover of my greatest common factor. And when I have negative 4x squared divided by negative x squared, what's left over? Negative negative is a positive. 4 and the x squareds cancel each other out. So I'm left with just 4. Alright. Here, my greatest common factor, I know 3 can go into 6 2 times. 3 can go into 15. Oh my goodness. So that's going to be 3. I've got a squared here and a squared here, so I can take out an a squared. I've got a b squared here and I've got a b. So I can't take out 2 b's because this one only has 1, but I can take 1 b out. So that's going to be my greatest common factor, 3a squared b. And what's left is 2b for my 6, and 5 is the only thing that's left because the a squared b cancel out. You divide it just like that. Alright. This last one, same thing. I've got my 9x squared y, 3x, 12x cubed y squared. So what do I see that is common among them? I see that they each are divisible by 3. So 3 I can pull out. I've got 2 x's here, 1 x here, and 3 x's here. So I can pull out at least 1 x. I've got a y here, no y's here, and 2 y's here. Since I don't have a y in this term, I cannot pull out a y. I can only pull out what's in each term. So this is my greatest common factor. And so then when I pull out 3x from x, 9x squared divided by y, and I divide that by 3x, I'm going to get 9 divided by 3 is 3. X squared divided by x is x. And y. So I get 3xy there. Then for the 3x, when I divide 3x by 3x, what am I left with? I'm left with 1. Any number divided by itself is 1. Then 12x cubed y squared divided by 3x, which is my greatest common factor, and that's going to give me 12 divided by 3 is 4. So that's 4. Then 3 cubed divided by x is going to give you x squared. If you're not sure how to do this, this is where your exponent laws come in. So make sure you know your exponent laws. And then y squared, I've got nothing to change that, so that just stays y squared. So this is what is left over from this term when I take out 3x. Alright, hopefully that makes sense. So when I'm factoring using a greatest common factor, step 1 is I have to find the greatest common factor. Then I divide each term by the greatest common factor, which is what we were just doing. Then, alright, so then you divide each term by the GFC, then you write the greatest common factor on the outside of the parentheses, and the remaining values of the terms on the inside. So let's do one. Here are some examples. So we've got 5x cubed plus 20x squared plus 15x. I see that for my numbers, my integers, each of them are divisible by 5, and that's the biggest one since that is my, since I've got 5 here, 5 I can't do anything bigger than 5. So I know that 5 is going to be divided in there. Then I'm going to look at my variables, and the x term, the most x terms that I have in there is 1x. So I'm going to take out 5x. When I take 5x out, I'm left with x squared for this first term, plus, when I take out 5 here, 20 divided by 5 is 4. If I take 1x away, I'm left with 1x. And when I take 5 away from there, I'm left with 3. If I take 1x away, I'm left with no other x's. So there is my answer. Now, you know me, and I like to check my answers. So if I was going to check my work, I would say, can I multiply and distribute this? Right? We've done this before. We've taken problems like this and distributed our numbers. We just haven't done it the other way. So when I multiply these out, am I going to get what I started with? That will check my answer. So 5x times x squared gives me 5x cubed, plus 5x times 4x is going to give me 20x squared. 5x times 3 is going to give me 15x. So are these the same? Yes, they are. So then I know I got it correct. All right, the next one. The biggest common factor for 12 and 20. 4 is divisible by 4, 12 is divisible by 4, 20 is divisible by 4. So I'm going to take 4 out. What of my variables can I take out? Well, this has 5 a's, this has 2 a's, this has 3 a's. So I can certainly take out at least 2 a's, a squared. And when I divide each term by 4a squared, what am I going to get? 4 divided by 4 is 1. A to the 5th divided by a second. If I take away 2 a's, I'm left with a to the 3rd power. Plus 12 divided by 4 is 3. When I take out away 2 a's, I'm left with no a's. Minus 4 divided by 20 is 5. When I take away 2 a's from 3 a's, I'm left with 1 a. So this is my answer. Again, if I were to check my work, I would multiply it as 4a squared times a cubed. It's going to give me 4a to the 5th because I add my exponents when I have the same base and I'm multiplying them. Then 4 times 3 is 12 a squared minus 4 times 5 is 20, or 4 times negative 5 is negative 20. A squared times a is a to the 3rd. So is this the same as this? 4a to the 5th, 12a squared. Perfect. Last one. So when I take away here, I'm going to actually look at this, and I see 2 goes into each one of these evenly. But I don't like to have a negative in the front. So I'm going to take out a negative 2. That's going to then change my signs. You know how that works. How many x's do I have? I've got 3 x's, 6 x's, and 4 x's. So I know I've got 3 x's, x cubed, in each term. When I divide, what am I left with? Negative 2x to the 3rd power divided by negative 2x to the 3rd power is what? 1. So that is my first term. My next one, 10x to the 6th power divided by negative 2x to the 3rd power is going to give me 10 divided by negative 2 gives me negative 5. X to the 6th power divided by x to the 3rd power gives me x to the 3rd power. So minus 5x to the 3rd power. Then negative 8x to the 4th power divided by negative 2x to the 3rd power is 4x. Negative 8 divided by negative 2 is positive 4x. These are the laws of exponents. X, 4 minus 3. Okay. Plus 4x. So this is my answer. If you are confused by this, let me just show you this. So this is no different than saying 10x to the 6th over negative 2x to the 3rd is the same as saying 10 times x 6 times, right? So that's 6, 1, 2, 3, 4, 5, 6. Divided by negative 2x 3 times. So when I do it that way, I cross these out, I get negative 5. These cross out, these cross out, these cross out, and I'm left with negative 5x to the 3rd power. Do you guys see that? Hopefully you see that. Alright, moving on. So you go ahead and try these. I'm not going to give you the answers to those. This one is very challenging, or not, depending on how you look at it. Does anything go in there, or do you see any similarities at all? No. Alright, so factoring by grouping. There's a few things you need to remember. First of all, you need 4 terms in the polynomial. And check to make sure they're in descending order. Okay? Those are 2 things for sure. Okay, then you get your GCFs, your greatest common factors, and then we're going to group. Okay? So, let's begin. So, I'm going to take the first 2 terms together. And I'm going to see, what do I have in common? Well, I've got a 2 and 5. Those have no common factors other than 1, and I don't really, I'm worried about 1 right now. But I do have common factors in the n and n squared. This has 3 n's, this has 2 n's, so I can take away 2 n's. When I divide by 2 n's, I'm going to get 2n, right? Because 2n cubed divided by n squared is going to give me 2n. Okay, when I take away n squared from 5n squared, I'm left with 5. Then whatever sign this is, you bring that down. So plus, now I look at these numbers. What do I have in common there? I know 2 goes into both, but 4 also goes into both. And that's about as much as I can do. 6 does not, 8 does not. Alright, so I've got 4. This has an n, but this one doesn't. So since this one does not have an n, I'm just going to leave it at 4. When I take 4 out, I'm left with 2n minus 4. 20 divided by 4 is 5. And there you have it. Alright, hopefully now you can look at this and notice something. These are the same. These should always be the same. That is what you want. That is good news. So what we're going to do is we're basically going to factor these terms out. And we're going to take these terms and move them to the side. So we're going to move 2n minus 5 to the side. And what are we left with? We're left with n squared plus 4. So I'm going to move those. I'm going to take my remaining ones and put them together as n squared plus 4. And this becomes my answer. And let me just show you why that is my answer. Because if I were to take these terms, and now we know how to multiply these two terms. If I was going to take these and put them in and multiply them together, n squared plus 4, right? You guys know how to do this. And 2n and minus 5. What would I get? And 2n times n squared is 2n cubed. 2n times 4 is 8n. N squared times negative 5 is negative 5n squared. Negative 5 times 4 is negative 20. Now I'm going to look. I do not have any common factors. So I cannot combine any common factors. I don't have any. So when I write in my equation, I'm going to write them in this order. 1, 2, 3, 4. The only reason why I'm writing them in this order is because I'm going by the exponents, descending order. And I get 2n cubed minus 5n squared plus 8n minus 20. Ooh, it's awfully close. And look at that. They're the same. So I know I factored that correctly. When you factor it out, these are going to equal each other. They're just in a different form. This is in a expanded form. This is in a factored form. There is a way to check your answer, so you can do that. All right, moving on. So here, I'm going to take my first two terms. I'm going to notice that 8 and 8, I can take an 8 out. M cubed, m squared, I can take m squared out. When I do that, I'm left with 1 in there minus, that becomes 8m squared divided by 8m squared is 1. Not 0, it's 1. I bring this down, and 7m, and I'm going to combine these and figure out how I can group those. 7m minus 7, 7. When I divide by 7 here, I get m. When I divide by 7 here, I get negative 1. Yay! Woohoo! I've done it correctly because I know that those are supposed to be the same. So my answer becomes 8m squared plus 7 times m minus 1. This is my answer. This is this equation in factored form. Okay? Number 2, combine these two. I'm going to notice my greatest common factor is 2 and b squared. When I divide 2b squared into 14b cubed, I get 7b minus 3. Now I bring this exact same symbol down, except for now that's a negative, so I have to be very careful with my negative. What am I going to pull out of here? 35 and 15. Well, I know 5 has something in common with that. 5 times 7 and 5 times 3. So I'm going to be good with that. Take 5 out. 7. I can't take the b out because this term doesn't have a b. So 7b. Now, since this is negative, a negative times a negative is a positive. So this must also be negative. So be very careful with that. And divide by 5, so I get 3. Here we go. Woohoo! So I get 2b squared minus my outlier here, 5. And then I get 7b minus 3. And there is my answer. Okay, 2 more. We do take this out. I get 3a squared. 3 goes into 24 8 times. A squared, so 8a. Minus 3 goes into 15 5 times. A squared goes into there 1 time, so I'm going to leave it like that. I bring this down. 8a plus 5, I don't have anything really that goes into those equally, so I'm going to say 1. However, since it's a negative 1, I'm going to change my sign. So that becomes positive 8a, and this will come negative 8a, or negative 5. And that also makes sure that those are the same. So then I'm left with 3a squared minus 1 times 8a minus 5. And there is my answer. Okay, now moving on to this last one, hopefully you're going to not just try and group these two because they're the first 2 terms, because what is one of the rules that we need? We need to make sure they're in descending order. So I need to rewrite this to be 16n cubed minus 64n squared plus 12n minus 48. Now that I've rewritten it in descending order, I've got my 3, 2, 1. Okay, so now I can group. And 16 actually goes into 64 4 times. So I'm going to take that whole 16 out. And n cubed and n squared, I can take that n squared out. And I'm left with n minus 16 goes into 64 4 times. And it's squared, so I'm left with just 4. Plus, I bring this sign down. 12 actually goes into 48, hopefully 4 times, but if you need to use your calculator and use the clues in this as to what you're wanting to get, do that. So I'm going to take 12 out, and I'm going to be left with n minus 4 times 12 is 48, so n minus 4. Yay! So then I get 16n squared plus 12 times n minus 4. Ta-da! And that's my answer. Alright, I hope this helped. I'll talk to you guys in class.